All right, any questions on the homework? There was one he did with a person riding a horse, and not only is the person done, he did the horse as well too.
I mean, the only thing I have to question is why does he find enjoyment out of cutting people and horses?
Well, they're dead.
They're dead.
Right.
That's
I mean, so no, you look at it from a more of an appreciation of the human form. I mean, why are all sculptures, or so many sculptures that we enjoy, why don't they have clothes on them? Is it purely from the woo, look naked, or is it from the let's look at the human form and appreciate it in its glory? You know, if you want to extend this to some people would extend it to a religious interpretation of, you're created by God and he makes perfect things, or you can take it to a completely atheist agnostic thing of the human body is beautiful types thing. I'm not showing you naked things, but I'm just saying this is why artists paint so many pictures of, the human body, is because we find it a pleasing thing, right? And I'm talking strictly from a aesthetic sense, not from a immoral sense type thing.
Yeah, and especially not a 15-year-old teenager.
Well, let's not even go there, but I'm just saying that is why so much art, very rarely do you see art of ugly things. Artists don't paint ugly things. Yeah. All right. Any questions on the homework? Oh, let me make this larger. Nobody wants to live in an ugly house. Nobody wants to buy ugly things. We like pleasing things. It does have a geometric interpretation, is that we find perfect geometry to also be pleasing as well too. We don't want to look at any circles that I draw, right? We're happy with circles that are perfectly drawn, which I can't do. You guys have heard of the golden ratio, yes? Right, we'll talk about that at some point this year, but there is a specific ratio as a fraction. There's a specific fraction, and it's believed, or the interpretation of it is, it's called the golden ratio. It is that anything that meets this golden ratio that's drawn in a specific proportion just is very pleasant to the human eye. So buildings, the body, all these things, other things in nature as well too. If they follow the golden ratio, then we as humans have agreed that this looks beautiful, right? Who gets to decide whether things are beautiful or ugly? That's a whole different topic, not a geometric topic. Okay, any questions on this? Was this easy or hard? Pretty darn easy, so I'm just going to collect it. And we're going to move on to a very, 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 very important class that's also easy. You will enjoy today's class.
Oh!
All right, so we are now beginning the fourth chapter of the book. The fourth chapter is probably the most important chapter of the entire book. It sets up, listen please, it sets us up to be able to do the rest of the book. The entire chapter is on triangles, just triangles. The entire chapter is on triangles. And as I said, as I introduced triangles to you last chapter, all polygons can be turned into triangles, which is why this chapter is the most important one. Since all polygons can be turned into triangles, then knowing something about triangles is how we're going to arrive at knowledge and understanding of all the other shapes and geometry. It starts off very easy today. No one is going to be challenged by today's. Now, there's a lot of stuff today. You got to pay attention. Just because I said it is easy doesn't mean, well, then I don't need to pay attention. I'm just going to say from a conceptual idea, today is easy. Tomorrow's a bit more challenging. Here's your homework. You need graph paper, especially for those that cannot draw things very well. Having a straight edge and graph paper will definitely, absolutely make your life easy. You will have to graph things accurately. So even though yesterday I taught you how to graph, or I showed you how to graph without graph paper, your shapes will be so messed up without graph paper as to render yourself incapable of finding the answers. So yes, you need graph paper. Danny? Well, you don't need it in class, but you're going to need it for the homework. Yeah. Hurry up. Boy. So tonight, we're only going to ask you to graph some things, literally graph some things, and you're going to need the graph paper to arrive at the answer. I guess technically, if you had really straight lines, you could do it by hand. It's just a whole lot easier with graph paper. There's only 13 problems. For some of you, this is where you're going to be introduced to the ability to manipulate objects in your mind. No, I'm not teaching you Jedi Knight tricks or something like that, but I'm saying you have to be able to think about shapes and turn them and twist them in your head. Okay? And for some of you, that's a challenge. Others of you will take to this like a duck to water. Some of you will I can't turn the triangle in my head. For those, I'm gonna ask for you just draw it a bunch of times, flip a little bit, then a little bit more, and then a little bit more. So literally, you're gonna take a triangle in your brain, flip it, and turn it. Right? You got to be able to do that in your brain, or you got to be able to draw it. Right? Okay. So it starts off. Matt, you don't even know what this is about. This is something called congruent figures. Now it says figures, so it could mean any shape. We're going to restrict ourselves today just talking about triangles. All right. So it's a short, easy class, but oh, is it important? So it's not time to turn your brains off. It's time to pay attention. There's lots and lots and lots of definitions. Some of them I'm going to ask you to write on this sheet of paper. Others of them in your book of truth. Okay? The ones that I say to write on this sheet of paper, I'm not going to say, well, you don't need to memorize them or remember them. But I'm just saying the ones in your book of truth are the ones that you're going to refer to over and over and over again. All right. Please stop me if you get lost at any point during the day. Right? So the first thing, in your book of truth, not on the sheet of paper, I'm just saying, in your book of truth, you're going to be talking for the rest of geometry about congruent figures. These are figures that have the same size, but they also must be the same shape. You can certainly have a triangle that has the same area as a rectangle. Hey, it's got 40 square units. Well, so does the triangle. The triangle is clearly not a rectangle. So if you are what's called congruent, you are the same shape and you are the same size. Hey, you see how much space is right here? I need you to leave this amount of space in your notebook. So however much space this took, leave this amount. We're going to fill two more statements underneath each other. We okay? Let me show you an example. That's a
triangle.
Okay. Is this one the same or different?
Different.
Well, is it a triangle?
Yes.
So we met the first requirement. It's got to be the same shape. Is it the same size?
No.
Can you tell from the picture? Can you tell? And the issue is here, you can't tell. I've taken the triangle, and by the way, it is the same one. I've taken it, and I've turned it, and I've flipped it, and twisted it. So that you can't tell just from the picture that they are the same size. You can certainly tell that it's the same shape. It's a triangle. So just from the picture alone, you can't tell that two shapes are congruent. Just from the picture. You need some extra information. The extra information will come in two different ways. Two different ways. The first way is it will literally tell you. You see what it says here? It says that this triangle is, so therefore they are congruent figures. How do I know they're congruent? Because it literally says so. We call this statement, take a wild guess, we call that statement a, what is it saying?
Congruency statement.
We call it a congruency statement, right? So how do you tell if two shapes are congruent? Well, one way of two is that you have a congruency statement that literally states that this shape is congruent to the next one. Okay, you got to tell me, yes or no? I said today was easy or hard. I said easy. So yes, you buying it? Are they congruent? Because it says so, right? Second way is there's going to be something on the picture that states that they're congruent. I'll show you that a little bit later. But the first one, the one we're going to spend the most time on, is the congruency statement. It says they're congruent. Now, this is not a proof, but if I took this thing right here and I flipped it, and then I laid it on top of the other one, right? You can see that, well, I didn't lay them up perfectly, but you can see that they are the same size and same shape, okay? And by the way, I did this in PowerPoint, so I know that they're the same shape. Okay. Two ways of telling whether two shapes are congruent. One, you either have a congruency statement, or two, there's going to be something about the shape that says that they're congruent. But I got to do a little bit of explaining first. Okay, in box 1A, this doesn't need to be in your book of truth. The corresponding parts. We've had corresponding angles, yes? Remember corresponding angles last chapter? What were corresponding angles?
They were ones in the same position on the
Same position, right? Same side, same position, right? Corresponding parts, well, sort of kind of the same idea. But what it's saying is that it's the same parts of congruent figures. So if I give you two shapes that are congruent, the corresponding parts are the parts that line up. The thing I just did with the triangles, where I laid one on top of the other, right? And they looked exactly the same. Those are the corresponding parts, the parts that line up with each other. If you could think of, and I don't have two identical twins, but when you have two identical twins and they're standing right here in front of you, I mean, they're called identical twins because they are identical. Their left hands look like their left hands, identical, right? Their nose looks like their nose. Those are the corresponding parts. If I take the two identical twins and I have one stand on their head, we don't say that their head matches their feet, right? We say that the head matches the head, even though they're flipped and rotated. That's what we're doing today. I'm going to give you two identical twins, but one of them I'm going to flip and rotate, and you got to match the parts. In other words, you have to find their corresponding parts. It's easy with identical twins, right? Maybe not left hand, right hand. You might have to give that some thought. But you're not going to mix up a head with a foot, right? With a triangle, you can. Triangles look too similar to each other. So you can mix up the parts. So hopefully I got a way of helping you with that, and I do. What's the help? The congruency statement. Okay, first off, if I line up these two triangles just like this, and I tell you that they're congruent, could you find the parts that match up to each other? We got two types of parts on this. What two types of parts do we have on these shapes? What do we got? We got the sides and we got the angles. Those are the two parts. Which one do you want to do first? Okay, let's do the angles first. I was lucky. Okay, angle A matches up with, can anyone not wrap their head around that? Okay, so angle D, this is the math symbol for corresponds to. You don't need to write that down. But this one arrow means corresponds to. So angle A corresponds to angle D, right? Well, what does angle B correspond to? What does angle C correspond to? Can anyone not wrap their head around that? Easy or hard? But what if I take the triangle and flip it and then rotate it? Now it becomes a bigger challenge, right? We said two parts. What was the other part that corresponds? The sides, right? Okay, so the side. So we got to pick a side. So pick a side over here.
BC.
Thank you for picking AB. So AB corresponds to, and we must make sure the letters go in the same order. So I go AB, I can't say ED, I got to say DE. You got that? So AB corresponds to DE, yes? BC corresponds to, and CA corresponds to, easy or hard? Until I take this, flip it, and rotate it, yes? So how in the world do you do that if I flip it and rotate it? You're going to use the congruency statement. Some people can look at the picture and they can do this in their head, very easy. Oh, it's been flipped and turned. I can do that. Many of us can't. It's a hard thing to do for some people. So when it has been rotated and flipped, I would always go back to the congruency statement. Don't look at the picture. All right, so that's the big but here, is that I'm going to rotate and flip it.
You said great, but
Okay, great, but, right, I'm going to rotate it and flip it. Okay, so DF goes with what? Is it BC or AC? Convince me, is it BC or AC?
you flip it back and face.
Well, how do you know?
You just rotate your head this way.
But how do you know I didn't flip it?
Oh,
See what I mean? So if I just turned it, well, then that's easy. Then DF goes with AC. But what happens if I flipped it like that? Well, now you can't commit yourself.
it's right there between BC and EF.
One more time.
BC and EF.
How do you know I didn't flip it?
Congruency statement.
Ah! So what we do when they've been rotate or flip, well, two things. Either you got to commit yourself with your brain, okay, let me turn it. Oh, it looks the same. Or no, wait, let me flip it. Oh, now it's the same. Or better yet, we're going to rely on the congruency statement. The congruency statement tells me everything. Check it out. What's the first letter? A would go with
D.
D. First letters go with first letters. So now I can tell what goes with A, C. A and C are the first and third letters, so AC goes with, and that's the power of a congruency statement. Okay? So we can do this whole process without the picture entirely, just the congruency statement. So I'm not going to do every one of them, but angle A would go with angle B would go with angle, don't let Matt answer all the questions, angle C would go with F. So there's your angles. All right? Can you see how easy that is with a congruency statement? All right, let's do sides. Maya, pick two letters in the first triangle. AB. AB would go with DE. Perfect. All right. BC would go with EF. And lastly, CA or AC would go with FD. Okay. And the order does matter. So if you say AC, then it needs to go DF. You say CA, then it needs to go with FD. Who's lost? Could you do that by yourself? But what happens if you don't have a congruency statement? What happens if I rotate and flip it and I don't give you a congruency statement? That's the most challenging one. You will have a couple of those tonight for homework. They are going to require you to do that rotating and flipping in your brain, which is why I said sometimes it might help to redraw it. If you can't do that, then you got to flip it and then convince yourself that they line up. So that's the so what about this, right? All right, now let me wrap what we just said for the last 5 minutes. The consequences of having congruent figure means that if you have two congruent figures, their corresponding parts match up. That's the consequence. So if you have congruent figures, their corresponding parts are congruent. This is what chapter 4 is all about, right? In fact, it has a very long saying that we abbreviate, or I should say we make a, we do an abbreviation for it. So corresponding parts of congruent figures are congruent. You want to write that in a proof? Corresponding parts of congruent figures are congruent.
No, so CCC.
Right. So I said that the shape that we're going to be dealing with this chapter is the, therefore we're going to say that corresponding parts of congruent triangles are congruent. Once again, that's a mouthful. That's a mouthful. That's a mouthful. I'm not sure why I showed this slide again. It's the same thing I just wanted to say. Oh, I'm sorry. This is what I want to say as well. When you are congruent, that means your measurements are equal. So great. Angle A is congruent to angle D. So if angle A is 80 degrees, how big is angle D? Because their measurements are equal. If AB is 4 centimeters, how big is DE? Because their measurements are equal. That's the second consequence. If the corresponding parts are congruent, that means their measurements are equal. Who's lost on that consequence? Cool. So we already have that in our book of truth, yes? We need to write this one. The consequence. that if you have congruent figures, the consequence is that the corresponding parts of congruent figures are congruent. That's a mouthful. In parentheses, I said that means their measurements are equal. If you're corresponding, your measurements are equal. If you're a congruent figure, that means your corresponding parts are congruent. Those two statements. Not a big thing to wrap your head around. Okay, great. Something is the same. The angles are the same, the sides are the same if they're congruent figures. We're not saying all the sides are equal to all the sides, meaning like one side's 4, all the sides are 4. That would be true for an equilateral triangle. But we're saying that if the parts match up, they're the same size. That's for angles and that's for sides. We're going to also find out it's true for area as well too, but that'll be for another chapter. If two figures are congruent, then their areas are congruent as well too. In other words, we wouldn't say the areas are congruent, we'd say their areas are equal. Got it? One more statement. Because we don't want to write this 50 gazillion times, and you will write this 50 gazillion times in geometry, we have an abbreviation. So guess what this stands for? Congruent parts of triangles are congruent. We call this CPCTC. You will be writing this. This is like the ending statement of, I don't know, 40 proofs that we will do. CPCTC. If you walk into a geometry classroom in March of any high school in America or China or Europe, anywhere there, you're going to hear kids say CPCTC, except they'll be using their own native language for that, right? Nobody writes this down. That's a long statement to write down. So we just write CPCTC. The corresponding parts of congruent triangles are congruent. And oh, by the way, it's a definition. It's not a postulate. It's not a theorem. It's a definition. That if we decide that two figures are congruent, then their corresponding parts are congruent. So we don't prove this. It's a definition. Which is why it says definition. CPCTC. I will have to remind you of this a couple times, and then, like I said, you know, you would be scared when once you know geometry, you're not scared. But if you were an Algebra 1 student and you walk in, oh, I'm going to go to a different school. Let me go look at what it's like to go to that school. And you walk into a geometry classroom, you get scared because the kids are saying stuff, and you don't understand what it means. All right. Last thing in 1B, write this down, a congruency statement. That's the other thing. This is a statement that indicates which parts are congruent, or in other words, which measures are equal. We like congruency statements. Unfortunately, we don't get congruency statements all the time. Tonight for homework, a couple of times they'll give you a congruency statement, but other times they won't. When you don't have a congruency statement, you must turn the shape with your brain. Or you can rely on one other thing that I said I would talk to in a few minutes. You're supposed to stop me if someone gets lost. No one's lost? Good. Who speaks Bailey? Do you speak Bailey? Anybody? So you can translate this for her? Did you get what I mean right there? What did I mean? Perfect. Because everybody understands things differently, right? So if you were to explain it to me, you'd have to speak Mr. C's speak, right? All right, we good? All right, this is an example. You don't need to write that. Here's a congruency statement. It says that this triangle is congruent to this one. It looks like a simple statement, but it tells me two things. It tells me which angles are congruent to which other angles. It also tells me which angles have the same measurement. It tells me which sides. So it tells me angles and sides. We've already done that a couple times. So this is a pretty powerful statement right here. If you get this on every one for homework tonight, your homework will be quickly done. You don't have this on every one for homework tonight. All right, but if you do, here, show us how easy this is. Angle R is congruent to which angle? Which one? Angle R is congruent to angle H. Wes, angle D is congruent to
No.
Q. Chris, F is congruent to. Hey, Seth's head's on. Or you got a big head, Seth. One or two. F goes with K. Yes? Cadence, FQ goes with. Chandler, DH goes with. And Jenna, RF goes with. Who's lost? With a congruency statement, easy or hard? Ridiculously easy. Except they're not going to give you a congruency statement on most of the homework tonight. Okay? I do want to just make sure you understand that not only is R congruent to H, that means their measurements are the same. Okay? Doesn't mean all the three angle pairs are congruent to each other. It could if it's equiangular, but it certainly means that R is the same as H, and that FQ is the same distance as KD. All right, I had another one, but we have this concept? Yes? No? Okay. Okay. Apparently there's lots of buts today. So what are you going to do if I don't give you a congruency statement? All right? Two ways you can do this. This is how I started, right? One, you can just look at the shape and you can turn it and you can flip it in your brain or draw it, right? The second way is if they're nice to you, they will give you some indication on the picture. It won't be a congruency statement, but they will give you some indicators. Now, I took a picture of this. It's kind of curved, so ignore it. It's supposed to be two triangles, right? It was right at the corner of the book, and it's an example in the book. Do you see the two triangles? There's some extra stuff there in red, though, right? What's the extra stuff there in red? It's telling me which sides are congruent, and it's telling me which angles are congruent. This is not a congruency statement, but it's showing me in the picture what sides are congruent to which sides. Okay? So angle N is congruent to angle, because this one has two arcs and this one has two arcs. Side RA is congruent to, don't mess this up. You messed it up. SU, right? Notice I went from 3 to 1. I got to do the same thing down here, 3 to 1. So notice there, this one is flipped this way. So like I said, some people can do this easily. Other people need to look at the tick marks or the arcs to line things up. So if you don't have a congruency statement, hopefully they give you this amount of information. Okay.
What happens if they don't give us that?
Something they're going to ask you in tonight for homework is they're going to ask you to write a congruency statement. So how do we do that? They're going to give you this picture. They're going to say, write a congruency statement. So that what they're asking you to do is write this thing. Well, this thing tells us what parts go with what parts. So could you do that with that picture? Here are the steps. Step number 1, tell me the name of that triangle. What's the name of that triangle? I don't know my black pens.
There's one right there.
All right, what's the name of the first triangle? And it doesn't matter which one you start with.
RAY.
So triangle what?
RAY.
RAY. Now we're told to write a congruency statement. Well, that means that they're congruent. All right, so what's the first letter? R goes with what?
S.
Keep going.
S-U-N.
Are you convinced that A goes with U?
Yes.
Ray, son, get it? Haha. Okay.
Oh my gosh.
All right.
That's bad.
That's how it's done. If they give you this picture, the congruency statement isn't hard to do. Okay? All right. It's not a fourth way of doing this, but the other way is instead of putting tick marks, they can also put numbers. If this one says 46 degrees, and this one says 46 degrees, they're telling you that they're congruent. If this side says 4 centimeters and this side says 4 centimeters, they're telling you they're congruent. So it can be done with tick marks and arcs. It can also be done with strictly numbers. Be ready for both. Okay? So I didn't choose what you guys said, but mine says Ari Ussen. right? Cool? By the way, you can write your triangle, what, 3 or 4 different ways, depending upon how you arrange your letters. So your congruency statement, when I called off the answer tomorrow, I'll say, right, it may not match the one that I write, but they could be perfectly fine. You just need to make sure that A goes with U, R goes with S, Y goes with N. Okay. And then remember, once you have a congruency statement, you can come up with these 6 relationships, or just from the picture, you can come up with those. I'm not going to have you do those, but you could get either one of these, or the information for these 6 statements right here, either from a congruency statement or from this picture. Yes? Connor, give me all 6 answers real quick. R goes with?
R goes with S. A goes with U. Y goes with N.
AR goes with?
US. RY goes with SN. And then YA goes with NU.
Perfect. Well done. Yes? All right. I had another one. All right. Do we need to do it? You got this? Be brave. And say, yes, we need to do this, or no, we got this. Nobody? All right. Skipping it. For those of you who did it. All right. Quick note. This idea extends to all polygons, not triangles. So even though we just focused on a triangle, this also applies to quadrilaterals, pentagons, hexagons, octagons, n-gons of any size. So for instance, if it tells you you have a rectangle ABCD, you might say that ABCD is congruent to rectangle EFGH. And then all of that applies. You can say, oh, A goes with E, B goes with F, so forth and so on. All right. Write this in your book of truth. We say that 2 polygons are congruent if and only if their vertices, that means their corners, can be matched up, that means placed on top of each other, so that all the corresponding parts are congruent. You can't say that this triangle is congruent to this triangle unless everything matches. If 2 out of 3 things matched, well, then they're not congruent. But if 3 out of 3 of the angles and 3 out of 3 of the sides are congruent, then sure enough, those polygons, and the triangles specifically, are congruent. 2 polygons are congruent if and only if the vertices can be matched up so that the corresponding parts are congruent. This sounds like a theorem or a postulate. It's a definition. This is how we define congruent figures. Hey, remember if and only if? Yep. We call that a, you may remember chapter 2. It says if and only if, that means it's a biconditional statement. It goes both ways, right? That means it can be read forwards or it can be read backwards. So the 2, you don't need to write this down. The 2 statements, and this goes for any if and only if, there's the 2 statements. So we could say 2 polygons are congruent if their corresponding parts are congruent. Or the other way, we could say if the corresponding parts of a polygon are congruent, then the polygons are congruent. Both ways. And since it's a definition, we don't prove definitions. We want to say then they're blue, right? Then that would be our definition. You get to determine that stuff. For the rest of the year, we're going to be proving that polygons are congruent. In other words, we got to show that all the parts of one are congruent to all the parts of the other. Sounds like a monumental task. There must be some shortcuts. Guess what the rest of the chapter is about? The shortcuts. Okay? We will start off with this definition. So starting off tomorrow, when we show that 2 triangles are congruent, we got to show that all the parts, that means all the angles and all the sides, match up perfectly with all the angles and sides of triangle number 2. And then we'll learn some shortcut methods. And you, by the way, you had me for pre-algebra. You already know a couple of these. You may not remember them. Tonight for homework, these problems can be challenging. You got to be able to manipulate the stuff in your mind. Maybe redrawing will help you a little bit. If you're given a congruency statement, it's a pretty easy task. You will not be given a congruency statement for everything. All right. I said it's a short class. I do want to do a couple classes. Don't do this often, but I want to show you a couple of these. All right. Suppose that you know that this, right, is congruent to this. Hey, what do we call this thing? So is our life easy or hard now? Our life is easy because they gave us a congruency statement. Danny, give me 3 pairs of corresponding sides that are congruent. That's an angle. Give me a side. How do we name a side of a triangle? How many letters do we need? Okay. How many? You choose at random. Okay. How many letters do we need to name a side of a triangle? What? Hold on. How many letters do we need to name a side of a triangle? If we name 1, well, which side are you talking about? Are you talking about this side or this side? We need 2. So now do it. I what? Okay, here's my triangle, FIN, right? Tell me a side. It is congruent. See my 2 fingers? Okay, give me 2 more letters. IN goes with, give me 2 more letters. You used FI and IN. Give me 2 more letters. Goes with. Okay, and we have to do it in the same order. So if you gave me NF, you'd have to give me BW. Okay, that would be like a half point off of a question. All right, very good. All right, give me the angles, Karis. It says give me the 3 pairs of corresponding angles. Keep going. All right, Madison, is this a true or a false statement? If this is true, is this a true or false statement? Nifbu? We're making up words here. She says it's false. Do you want to agree or disagree? She says that NIF does not equal or is congruent to BEW. So three fingers. So NIF, that's the order. Got to be the same order. BEO, that's true. Caleb, last one. True or false? INF, EBW? False. Let's see. INF. INF. That would be EBW. Yeah, you're right. It's false. Yes? Did you see that? Why that one was false? Middle right first. Needs to go middle right first. That's EBW, not EWB. Okay? Easy or hard, those questions? Those are easy. Hey, look up here. Do we have a congruency statement? This is the hard one. So let's do this one. It says the two, do you see 2 triangles? First off, okay. We got top triangle, bottom triangle. It says the 2 triangles are congruent. All right. And it says that triangle ABO is congruent to it and it doesn't have another thing. So let's see. ABO. Can you follow the pattern on the other triangle? So what did you say? He said COD. You guys agree or disagree? This is a skill of being able to flip this. If I rotate this like this and then slide it up that, would it match or not match?
Well, I think you would have to turn.
He's claiming I would have to turn it and then rotate it. You see what I mean? You got to do this in your head? This is a hard task for someone. I'll just say this. It appears that this side is long, yes? It appears that this side is, well, which sides would match up there? Well, clearly this side matches up with that side, right? So we're just talking about these 2 sides. I got a short side and I got a long side. Well, which is the short, which is the long side? Well, here's your short side that matches with this. Here is your long side. Here's your long side. So, and then lastly, top and bottom match up. So let's see. It said ABO. Well, we're not starting here because that side attaches to the double side. That would be the C. So CDO is what I would say. This is hard, right? You got to flip these around your head. But once that's done, once you get one congruency statement, what is it? Somebody, what was it? CDO. Once that's done, then the rest is simple, right? You just look at the congruency statement. Don't look at the triangles ever again. But you got to get the congruency statement correct. Okay. Cool. All right. I just wanted to show you that one because that's probably the hardest one. Now remember, this concept also applies with any polygon. So clearly we got 1, 2, 3, 4, 5. We got a pentagon. Remember I said they could also give you side measurements as well too, except tick marks or angle measurements. So it says that the two pentagons are congruent. Okay, so which side does it look like is 5 on the other one? Which side it looks like 5 on the other one? Okay, you got that. Which side looks like 4? And which side looks like 4.5? Okay, well that one isn't too hard. And then you can match up the rest. So occasionally they won't give you that. So, and they have a mixture of measurements and tick marks or arcs as well too for angles.
Is it literally black force?
Is it?
It is.
Okay, it's geometry. They got to put something in there, right?
Yeah.
So clearly it's BLACK goes to HORSE. Fun.
Wow.
All right. These are the hardest ones. I believe there's a couple of these tonight for homework. No? One of the homeworks that we do has something like this where you're trying to match things up. This is harder, right? So which leaves are, it says the 5 leaves are all congruent. But one differs. Well, if they're all congruent, how can they be different? So they just mean that one is flipped over. They're still congruent, but it's flipped over. So which one could you not rotate around and match up? This one?
Yeah.
So if I flipped it around, would it ever match that? No. If I flipped this one around, would it match that one?
Yeah.
And it could match this one if I kept rotating around and match that one. So yeah. So the bottom left, this is IQ test sort of stuff. If you ever taken an IQ test, they have you look at shapes and have you manipulate it in your head, right? I'm not claiming this is a measure of intelligence, although IQ test makers are. They always give you tests like this. I argue the reason why they give you this is because, well, you can do this with pictures and not words. Although there's a lot of words with them.
Yeah.
We good? Was I right that today was easy? Okay. Okay. Why do you need graph paper? Because they're going to give you a couple questions tonight that require you to put the shapes on a graph. Okay? Could you do it by hand? Yeah, I guess you could. If you had perfect handwriting and perfect ability to draw shapes, most of us are not that perfect, and we need graph paper to do this. So please use graph paper. And that's all she wrote. We are done. Oh, homework.
Here I thought I could go the entire school year without needing graph paper.
Tomorrow will be the only time that I literally get to cursing class legally.
Ooh.
Do you remember the class from pre-algebra?
No.
Yeah.
She remembers. All right.
Never took a pre-algebra.
There's only one joke that you can make in geometry, and this is the one, and
This is the one.
it's tomorrow's class. And so all math teachers get giddy because they're like, ooh.
Oh, is it ASS?
Yes. All right, e-learners, you have any questions, let me know. So you remember that from pre-algebra, Seth?
I didn't take pre-algebra.
Then how do you know about ASS?
It's a